The deployment of the Rheinmetall-Borsig electrostatic proximity fuse in the spring of 1943 occurs at the absolute critical turning point of the European air war, fundamentally shattering the Allied strategic bombing campaign. Prior to this technological pivot, German anti-aircraft crews had to rely on complex visual tracking, acoustic locators, or early Würzburg radar systems to manually calculate the altitude of incoming bomber streams, setting mechanical time delay fuses to detonate shells in a localized box of shrapnel. If a shell missed its calculated altitude by a mere few meters, it flew past harmlessly. Proximity fuses instantly erase this margin of error, turning every near miss into a devastating ship-killing detonation. When the United States Army Air Forces and the Royal Air Force launched their massive daylight and nighttime raids over industrial centers like Hamburg, Schweinfurt and Regensburg in mid-1943, they fly into an absolute wall of mechanical execution. A post-war United States Air Force study concluded that equipping the German Flakwaffe with proximity fuses would have increased their weapon effectiveness by an astronomical 340%, a calculation that is fully realized in this alternate timeline. As the heavy bomber streams of B-17 Flying Fortresses and B-24 Liberators enter German airspace, they are systematically torn to shreds by high-density proximity-fused 88 and 105mm flak fire. The devastating airbursts do not merely damage individual bombers, they create vast overlapping spheres of high-velocity shrapnel that shred wings, puncture fuel tanks, and decapitate aircrews without warning. Historically, the Western Allies considered a 5 to 10% loss rate per raid to be the absolute limit of strategic sustainability, a threshold they dangerously approached during the real-world Schweinfurt raids. With German proximity fuses active, Allied bomber loss rates multiply instantly, skyrocketing to an unsustainable 25 to 30% per mission. Squadrons are wiped out in minutes, and the sky-high casualty rates make daylight bombing operations with B-17s an absolute statistical impossibility, while B-24 Liberator operations are rendered completely impractical and discontinued. By the autumn of 1943, the catastrophic rate of attrition forces the Allied Combined Chiefs of Staff to order an indefinite halt to all daylight strategic bombing campaigns over Germany. The consequences of this forced retreat are immediate and far-reaching for German war production. Without the relentless round-the-clock bombardment of German industry, critical synthetic oil refineries, ball-bearing plants, locomotive networks, and advanced aircraft assembly facilities remain entirely intact and fully operational. Free from the constant necessity of dispersing factories into underground mines, German Armaments Minister Albert Speer is able to maximize industrial efficiency, doubling the output of fighter aircraft, heavy artillery, and defensive munitions, thereby lengthening the European war by months or even years. In the high-stakes technological race of the Second World War, the development of the radio proximity fuse stood alongside the atomic bomb and radar as one of the most closely guarded military secrets of the Allied coalition. Introduced by the United States Navy in early 1943, this revolutionary technology acted as a miniature, self-contained airborne radar, detonating anti-aircraft shells automatically when they passed within 50 feet of an enemy aircraft, thereby bypassing the necessity of a direct kinetic hit. While the Allies successfully deployed these variable time fuses to devastating effect, Germany's own extensive research into over 30 proximity fuse designs spanning acoustic, electrostatic, and radio wave systems was completely paralyzed by bureaucratic dysfunction and short-sighted leadership. Most catastrophically, in 1940, Adolf Hitler issued a sweeping strategic decree banning all military research and development projects that could not guarantee frontline deployment within a single year. Consequently, Germany's most promising and highly mature design, the Rheinmetall-Borsig electrostatic proximity fuse was abruptly shelved just as its core technologies were demonstrating remarkable potential. In this alternative timeline, German military planners successfully lobbied to exempt advanced electronic research from Hitler's restrictive decree, prioritizing the electrostatic project as a strategic necessity for homeland defense. Free from political interference, Rheinmetall-Borsig engineers embark on an intensive, uninterrupted development program throughout 1940 and 1941. The technical genius of the German electrostatic design lay in its absolute simplicity and resistance to external disruption. Unlike complex radio frequency fuses that required fragile chemical-based batteries, the electrostatic fuse operated on the principle of measuring the change in electrical field capacity as the shell neared a large metallic mass, such as a multi-engine Allied bomber. The insulated nose cone of an 88mm Flak shell was completely isolated from the main steel body, acting as a giant capacitor. Upon firing, the immense centrifugal force of the shell's rotation flung out a tiny, hair-thin wire antenna from the nose. As the projectile whipped past an enemy bomber, the metallic hull of the aircraft disturbed the surrounding static field, inducing an alternating current that instantly triggered a highly sensitive cold cathode thyratron tube to detonate the main explosive charge. By mid-1942, continuous prototyping and rigorous testing against towed metal targets pushed the reliability of the Rheinmetall-Borsig fuse to an unprecedented 95% within a lethal 4-meter kill radius. Crucially, because the system relied on static field capacitance rather than active radio signals, it was entirely immune to the electronic chaff and window jamming tactics that the Allies would later deploy. Furthermore, the absence of active radio transmitters made the fuses incredibly cheap to mass produce, requiring only a fraction of the strategic materials needed for Allied vacuum tubes. With tooling finalized by the autumn of 1942, German assembly lines begin churning out millions of electrostatic proximity fused 88mm shells. And by the early spring of 1943, the first massive stockpiles are delivered to frontline Flakwaffe batteries, protecting the industrial heartland of the Reich. Following the total paralysis of the Allied strategic bomber offensive, German military planners quickly adapt the Rheinmetall-Borsig electrostatic technology to their ground artillery forces, unleashing a terrifying new dimension of tactical warfare on the battlefield. Historically, artillery was fused to explode upon direct physical impact with the ground, a design that allowed advancing infantry to escape lethal shrapnel by instantly diving into deep trenches, foxholes, or natural depressions in the terrain. Proximity fuses completely reverse this basic survival equation by enabling perfect, pre-calculated airbursts. When fired from German heavy field howitzers, such as the standard 10.5cm LEFH-18 or the massive 15cm SFH-18, the electrostatic fuses detonate shells precisely 10 to 30 feet above the ground, spraying a continuous downward rushing cone of razor-sharp steel shrapnel. The tactical effect of these proximity-fused airbursts on Allied infantry is absolute annihilation. Standard field fortifications, foxholes, and open trenches, the primary defensive lifelines of the modern infantryman, offer absolutely zero protection against shrapnel raining down vertically from above. During the historical Battle of the Bulge, the Allies had briefly utilized their own proximity-fused artillery in a ground roll, achieving an astonishing 70% casualty rate against exposed German infantry, compared to a meager 5% for traditional impact-fused shells. Now, with the technology weaponized by the Wehrmacht, advancing American, British, and Soviet armies are subjected to this mechanical horror on a colossal scale. Entire infantry battalions are decimated in open fields before they can even make visual contact with the primary German defensive lines. Their advance is shattered in a matter of minutes by inescapable overhead steel storms. Beyond the catastrophic physical casualties, the psychological impact of electrostatic airburst artillery completely paralyzes the operational capacity of Allied frontline troops. The terrifying realization that digging into the earth offers no safety and that any open terrain is a potential death trap induces an unprecedented wave of severe shell shock, combat fatigue, and psychological collapse among surviving soldiers. Frontline units suffer a total breakdown in morale as troops refuse to leave the cover of armored vehicles or concrete structures, stalling key Allied offensive operations across both the western and eastern fronts. German defensive lines, heavily supported by high-density airburst artillery, become completely impenetrable, turning every Allied tactical assault into a costly, demoralizing slaughter. The dual mastery of the proximity fuse in both the air and ground theatres completely alters the geopolitical map of Europe by 1944. On the Western Front, the absolute dominance of proximity-fused air defences extends to tactical operations, neutralising the Allies' primary battlefield advantage, tactical air power. Mobile German anti-aircraft units, utilizing armored Flak panzers equipped with rapid-fire 37mm and quad 20mm guns, firing proximity-fused ammunition, easily swat low-flying Allied P-47 Thunderbolts and Hawker Typhoons from the sky. These tactical fighter bombers, which historically paralyzed German troop movements and supply columns throughout France, are rendered entirely ineffective, allowing the Wehrmacht to move reinforcement divisions and heavy armor in broad daylight with absolute impunity. When the Western Allies attempt to launch the D-Day invasion of Normandy in June 1944, they land in an absolute tactical nightmare. Deprived of the strategic air superiority that had historically flattened German coastal defences and isolated the beachheads, the Allied armada is subjected to relentless, devastating bombardments from German batteries firing proximity-fused airburst shells. The landing beaches are transformed into giant, inescapable killing zones where troops are pulverized at the water's edge and landing craft are shredded in the surf. The total failure of the Normandy landings forces a battered, deeply demoralized Allied force to withdraw back to Great Britain, delaying any future cross-channel invasion attempts by several years and leaving the United States and Great Britain with no viable path to challenge German hegemony in Western Europe. Meanwhile, on the Eastern Front, the Soviet Red Army's massive armored steamroller is ground to a brutal halt. Deprived of tactical air support and decimated by deeply layered fields of German proximity-fused airburst artillery, the massive Soviet infantry offensives dissolve into a grueling static war of attrition reminiscent of the Western Front of the First World War. Realizing that the continuation of the conflict will result in the complete exhaustion of their manpower with no prospect of a decisive military breakthrough, both the Soviet Union and the Western Allies are forced to abandon their demands for unconditional surrender. By late 1944, the warring powers enter into agonizing peace negotiations, leading to a negotiated armistice that leaves a heavily militarized German Reich in possession of its occupied territories, proving that a single tiny electronic vacuum tube, perfected by German engineers in defiance of administrative neglect, was the ultimate strategic lever that broke the back of the Allied war machine.